pass another. Okay. My name is Badea Lepadatescu, and I present the statistical analysis of the biological and ecological aspect of grinding fluid on quality of part using SPSS program. Next. Statistical analysis. The steps are the first: introduction, internal grinding and cutting fluid using machining, cutting fluid using internal grinding, evolution over time of the property and characteristic of the cutting fluids during processing, measurement of cutting fluid during abrasive processing, and conclusion. As an introduction, grinding is a cutting process that is usually carried out at high cutting speeds, which involves the release of a significant amount of heat, which, as a rule, also causes unwanted effect on the workpiece, decarburization, soft spot, burns, rectification, cracks, etc. That is why, until now, it has been considered that the cutting fluid that best meets the requirement imposed by this processing procedure are emulsion, which ensures the rapid evacuation of the heat from the cutting area. But the research on them was formulated under the condition of using some conventional abrasive. This is why the paper is also centered on the analysis of the nature and properties of the cutting fluids used for grinding with abrasive bodies made of cubic boron carbide, which exhibit a high hardness, abrasion resistance, and thermal conductivity when compared to conventional abrasives such as aluminum oxide and silicon carbide. The advantage of using grinding oil as a cutting medium for grinding are increasing the productivity of processing, tangential force are lower, the required power is lower, the heat developed in the grinding process is lower, so we can work with a more intensive cutting regime. 2. Reducing the consumption of the abrasive bodies due to the reduction of the forces that develop during the cutting process. 3. Improvement of the quality of the processed part, decrease in the roughness of RA. 5. Improving the health of the operator. The bacteria that grow in the watery cutting fluid are harmful to the health of the operators. The disadvantages of using oil as cutting fluid for grinding are 1. Low calorific capacity and low conduction capacity from the cutting area. 2. Fulfillment of necessary precondition for safety of the operator and the machine as tight closing of the machine tools, machining equipment, tools with exhauster, aerosol and oil vapor exhaust systems. Next one. Internal grinding and cutting fluid used in machining. The experimental tests were carried out on an internal grinding machine with roller and shoe grip. The processed parts have an outer diameter of 17 and 18 respectively and an inner diameter of 11 mm, made of material 100 chrome 6, hardened and tempered to 6062 harness Rockwell cone. The parts are processed simultaneously. 2 parts are processed simultaneously. Processing allowance is 0.50 mm per diameter, abrasive body CBN. Machine is equipped with a system for recognizing the contact between the grinding tool and the workpiece. Abrasive stone performs the main cutting motion and the transverse advance and oscillating movement. Cutting fluid is cut max grinding oil from. Samples of parts are taken from batches of parts of 2 different external diameters, 17 and 18 mm, processed with the same type of abrasive body, cutting regime and the same allowance of material. The spread of the outer diameter value is in the range of 3 micrometers. From the analysis of the box plot graph 2 and table descriptive statistic table 2 is found that there is differences between the roughness of the part processed with the clean cutting fluid and with the one loaded with the impurities. but these differences are not very big. Under the condition in which the concentration of impurities in the cutting fluid increased a lot, the roughness of the processed part was changed but not very large. Cutting fluid, use it in internal grinding. There are generally 4 types of cutting fluid, as you can see in this figure, commonly used in machining operator: oils, emulsion, semi-synthetic, and synthetics. The most common method of applying cutting fluid is flat cooling, where flow rate ranges from 10 liters per minute for a single point tool and to 225 liters per minute for multiple tooth cutters. Cutting fluid, as well as other metalworking fluid used in manufacturing operation, may undergo chemical changes as they are used over time due to environmental effect, as well as the contamination from various sources, including chips and metal fine microbes, bacteria, mold, and yeast, particularly in the presence of water, and adversely affects the property and characteristic of the fluid, thus influencing machining operation. Samples of parts are taken from batches of parts. This was another. Next. Yeah. Evolution over time of the properties and characteristics of the cutting fluid during processing. Semi-synthetic emulsion castrol hydrol. To observe the evolution over time of the grinding emulsion, the following parameters were measured and recorded for 80 days. The pH value, the concentration, the content of the foreign oil, diameter of the water with a wear mark when the force of 13 decanewton is applied for 30 minutes. It is observed in figure 4 and 5 that if the value of pH, concentration, and wear mark were stable over time, the foreign oil concentration recorded very large variation, which means a strong contamination of the system centralized with foreign oil from the hydraulic and lubrication installation of the. From analysis of the figure 7, it found that there is a strong variation in pH of the emulsion, although the correction made try to stabilize the pH value at 8.8 to 9. There are extreme value of the pH of the solution located outside 3 box lengths of the median value. It is observed that there is a significant positive correlation between the concentration of the emulsion and the pH value. The value of the threshold of the significance less than 0.003 shows that we can state this with a possibility of error less than 3%. Conclusion: the centralized system of cutting fluid is a dynamic system with a continuous evolution over time. 2. Due to contamination with impurities, evaporation, foaming, loss of liquid of part, development of bacteria, etc., the concentration, the pH, and diameter of the wear mark change over time. 3. During the analyzed period, frequent cases of foaming and the emulsion were reported. 4. Although cause a health problem of the operator, new problem or aggravation of skin or respiratory disease have been reported. 5. High value of foreign oil concentration indicate a strong contamination of the centralized grinding emulsion system. Through the maintenance measure of the centralized installation, the content of foreign oil decreases, only to return to alarming value after a few days. Next one, please. Synthetic emulsion Scintilo 290 castrol. Characteristic parameters of the grinding emulsion were analyzed when the emulsion was considered damaged due to the high concentration of foreign oil, up to 0.2%. Analyzing comparatively the pH value and concentration of synthetic and semi-synthetic emulsion, it can be seen that the pH value is much more stable for larger variation in the concentration of synthetic emulsion. This can be explained by the much higher double content of foreign oil in the semi-synthetic emulsion than the synthetic one. Conclusion: characteristic parameters of the synthetic rectification emulsion change over time. After monitoring the characteristic parameter of the emulsion and making the required correction, the pH and concentration values are kept within certain stability ranges. 3. During the period of the use of emulsion from the centralized system, approximately 3 years, no quality problem of the processed part were reported. 4. Following the contamination of centralized system with foreign oil from the hydraulic installation of the matching tools, there were problems with the emulsion filtration, which ultimately led to a need to replace the chipping fluid. Management of the cutting fluid during abrasive processing. Specialists have noticed that the main characteristic of the grinding process is a large contact surface between the cutting tool and the processed piece, as well as the difficulty of bringing the cutting liquid to the cutting area, which leads to the release of the large amount of heat and difficulty of taking it over by the cutting fluid. Aiming to reduce manufacturing costs as well as the scrap and rework costs, the technological engineers focused their attention on optimizing the flow of cutting fluid in the grinding area. The 3 directions of investigation are the required flow rate of the cutting fluid, the necessary pressure of the cutting fluid, and the way it is conducted in the abrasive tool part contact area. With the expressive power of the metaphor, it can be stated that the cutting liquid is a living system which undergoes changes over time under the influence of external factors with which it interacts. Oxygen from the surrounding air causes the oxidation of the liquid, impurity entering the liquid from water, from the part, from the hands, and the operator. They represent environments conducive to the development of the bacteria. The viscosity changes due to the heat absorbed in the cutting process. Liquid loses volume through evaporation and through the adhesion of the part. Concentration correction. Correction of the pH value. In general, pH is between 8.5 to 9.5. Is recommended for emulsion use in cutting the liquid for rectification. Control of development of the bacteria and fungus. The way to overcome the presence of bacteria. The problem generated by the presence of bacteria can be overcome through the following ways. A careful selection of the raw materials used in the manufacturing of cutting fluid. Organic materials such as mineral oils are culture medium par excellence. Maintenance of individual or centralized cutting fluid system. In fact, that is the most effective way to control the growth and development of bacteria. Bacteria growth can be slowed by maintaining a suitable concentration of the cutting fluid, prevention or minimization of contamination, good practices for cleaning and maintenance of the lubrication cooling system, a good filtration of the cutting fluid and a continuous removal of the chips, a periodic cleaning of the tanks and aeration of the emulsion. The way to reduce the influence of fungi contamination. Generally, as with bacteria, minerals in the water help fungi grow, so removing minerals from water is the first step in reducing the process. In the event of the major fungal contamination, the liquid in the individual or centralized system must be completely replaced, and then the installation element must be thoroughly cleaned to remove the contamination, also by mechanical action. As a rule, chemical cutting fluid are more susceptible to fungal contamination than emulsion. On the other hand, emulsion constitutes a more favorable environment for the development of bacteria. Fungi growing in centralized cutting fluid system lead to cutting fluid odor alteration and pipe clogging. Each job is characterized by its own set of vulnerabilities and risks. All types of cutting fluid can cause skin irritation and dermatitis. Among the cases that cause skin irritation can be listed: water miscible cutting fluid following exposure to certain chemical component or contaminants, non-emulsifiable oils in regular and prolonged cutting with the skin. Exposure to cutting fluid mist can cause eye, nose, and throat irritation and occasionally cause breathing difficulties such as in bronchitis and asthma. In the case of water miscible fluid, breathing difficulties may be due to exposure of sensitization to chemicals and the fluid or sensitization of bacteria that may contaminate the fluid. The use of unrefined mineral oils. The most numerous health problems for grinding shop operators are related to dermatitis. Occupational dermatosis are the term used to describe any skin abnormality induced or aggravated by the work environment. Dermatitis has a certain specificity, referring only to inflammation or irritation of the skin. Occupational dermatitis is characterized by the type as follows. Primary irritation results from the direct action of the skin in the place of contact, during contact or immediately after. Sensitization is a result of an allergic reaction response of the immune system to a given substance. Initial contact with the substance may cause irritation but may cause sensitization to the substance after a period. Once the skin is sensitive, even a small amount of the substance can lead to a severe reaction that is not limited to the site of contact. Photosensitization is like sensitization, except that the presence of light is necessary to activate the sensitivity. Factor for appearance of dermatitis. The specific factor for appearance of dermatitis associated with the use of cutting fluid are alkalinity. In general, cutting fluid with pH greater than 9 should be avoided where prolonged contact with the operator's skin is expected. Acidity. The main source of acidity in rectification is water miscible fluid is contamination with oil that contain components with active sulfur or chloride that break down in the presence of water and form weak acid. Solvent. Organic liquid with a low boiling point such as 3-chloroethane, carbon tetrachloride, kerosene, benzene led to serious skin damage. Dirty cutting fluid. Impurity from the chipping liquids such as fruit or vegetable seed, cigarette, then can be irritating themselves. And biocides. The wrong use of biocide can be extremely harmful to the health of the operator in general and to the skin. Biocides are generally substances with a very low or very high pH. As a conclusion, exposure to high level of airborne emission may lead to respiratory tract irritation. Irritation problem can be associated with inadequate provision for fluid in the cutting area, improper use of additives, high concentration of cutting fluids, high density of machine tools in a limited area, inadequate fog collection system, poor workshop ventilation, and insufficient amount of fresh air in the workshop. Another one. This reference is another one. Last one. Thank you very much for your attention.